Hello everyone, we are going to talk about chain rule of differentiation now. Chain rule is used to differentiate composite functions. It differentiates a composite function by creating a chain of derivatives starting from the outermost layer. Now, what does that mean? Well, it means that if you are given a composite function f of g of x and you want to differentiate it, then the derivative is given by f prime of gx times g prime of x. Okay, so the derivative of outermost layer leaving the inner layer intact times the derivative of the inner layer. If you want to apply it recursively for a function that looks like this, f of g of h of x, and you want to use chain rule to find its derivative, then this is what you do. Take the derivative of the outermost function, keeping the inner layers intact, times the derivative of the inner layer, keeping the innermost layer intact, times the derivative of the innermost layer. As you can see, we have a chain of derivatives here, hence the name chain rule. Okay, now let's get to the first example here. You're given a function f of x, which is the 10th power of 2x squared plus 3. Let's start with part number A. Part number A says, show that your given function f of x is same as g of h of x. So let's start here. Let's start to evaluate this. This is same as, and therefore you can see this is same as f of x. So part 1 is done. We have verified that the function f of x is a composite function. Second part says find f prime x. Since f of x is same as g of h of x, therefore finding the derivative of f means finding the derivative of this composite function, which will be g prime h of x times h prime x. Now we don't know all these things, so we have to find them first. So let's go ahead and start with h prime x, which is the derivative of h of x. This is h of x. Its derivative will be 4x plus 0, or you can say just 4x. Note that g prime x will be the derivative of x to the power 10, which using the power rule is 10x to the power 9. As a result, g prime of h of x would be g prime of 2x squared plus 3, which is same as 10 times 2x squared plus 3 to the power of 9. Now we have all the things that we need. Let's plug them back in. Great, we have finally found the derivative of f. The only problem is that this process seemed a bit tedious. So is there a shortcut? Is there a way I can find the derivative directly just by looking at the function? Let's see. Let's try to analyze this a bit further to see if we can really do that. All right. If you're given the function x to the 10, finding derivative was pretty easy. The derivative was 10x to the 9. Using which rule? Using the power rule. But what if I have to find the derivative of function which looks similar to this but is not exactly like this? For example, if we have a function of the form something to the power 10, then how do I differentiate it? Well, chain rule says that you can differentiate it just like before. Okay, so you bring this exponent to the front, you reduce the power by 1. But the extra thing that you have to do here is that you have to multiply with the derivative of this box, because this box is not the x that was given to you. I repeat, this is the only extra thing. All right. Let's take an example to understand that. The function here looks like box to the power 10. So the derivative will be 10 times the box to the power 10 minus 1 times the derivative of this box. Please note this box is actually the inner layer of your function, and you have to make sure that you multiply with the derivative of the inner layer. So this is the only extra thing here. Make sure you remember to keep it with you. The derivative of 2x squared plus 3 is 4x, and you are done. Let me give you one more example so you are sure. Go ahead and find the derivative of the function Note that this function can be written as again, as you can see, this is something to the power 1/2. So to differentiate this function, differentiate a function which looks like this, we are going to do half times the box to the power 1/2 minus 1 times the derivative of that box. The derivative of 3 times x to the 5 is 15 x to the power 4. The derivative of 7x is 7